everybody. In today's session, we will study units. Now all of you know that for correct measurement, we need standard unit. Otherwise, there will be confusion. In good earlier days, people used to describe various physical quantities by rough or crude units or approximately. But they soon realized that there should be some standard system, and different systems of units came into existence. And from your lower standard knowledge, you know that there are systems like CGS, MKS and FPS. Now look at this diagram. Now CGS means centimeter, gram and second. MKS means meter, kilogram and second. And FPS means foot, pound and second. Now we know that this FPS or European system still we use at some places. For example, suppose you wanted to describe the height of any person, then still we say that it is 5 feet 3 inch or 5 feet 2 inch, like that. Or area of any room, normally we describe by room is 10 by 10, means 10 feet by 10 feet. Or even newborn baby's weight is also described as few pounds. Initially, only 3 units or 3 units for 3 physical quantities were used, length, mass and time. But soon scientists realized that other units or other physical quantities you cannot express with these 3 basic units, and you need some more units, and otherwise you cannot describe that physical quantity completely. For example, electric current, then thermodynamic temperature, amount of substance, luminous intensity, like that. And then more general or rather comprehensive system, SI system, came into existence. And this system is accepted by throughout the world, therefore it is called as international system. And this system consists of some basic units. Now look at this diagram where you can see these units. Now these units are sufficient to express all physical quantities. Of course, along with this, for measurements of plane angle and solid angle, you need 2 more units, radian and steradian. Look at this figure where you can see these units. Thus, these 7 units for length, mass, time, electric current, temperature, amount of substance, luminous intensity, and supplementary units, radian and steradian, are sufficient to describe all physical quantities. But other than this system, some units are traditional units, and being convenient or all people understand, therefore these units are still used for general purpose. Now look at this table or this diagram where you can see that minute, hour, day, year or liter, ton, like that. So these units are also still used, and there is no any harm in using these units, or there is no confusion, because all people are familiar with this. For example, if somebody asks you what is your age, then you may say that 16 years or 17 years, like that. And if you convert that into seconds, then you will get that such a huge number, say 5.3 into 10 raised to 8 seconds, or 53 crores 61 lakh and 12,000 seconds. If you tell somebody this is my age, then there will be some confusion for this, or that person has to convert that into years, and then he may ask you that why don't you tell that I am 16 years old or 17 years old. Then you cannot say that no, I am strictly following I am SI system, so I have to express in second. No, it's not like that. So some units which are convenient or traditional unit, still we use it. But for calculation purpose, we use the SI system, or SI system is preferred. So there is no any harm in retaining or using this convenient unit or other traditional unit, and it becomes very small number also. Instead of describing the age of the person in seconds, years is a convenient thing. Those who have studied the SI system or various system, they can understand how to convert it. But for common man, it is very difficult. Therefore, these units are also still in use, or without any harm, we can use it. We should know the conversion factor properly. For example, 1 meter is equal to 100 centimeter, or 1 kilogram is equal to 1000 gram, etc. So, for conversion from one system to other, we use different conversion factors, and these conversion factors are expressed with the help of some prefix. So look at this diagram. This is the metric system prefixes, where this deci, centi, milli, micro, nano, pico, femto, atto, etc. are mentioned. And in the last column, it is shown that how to pronounce it, that millionth part, billionth part, like. This is for smaller. Similarly, you can express it for bigger quantities also. 100, 1000, million, billion, trillion, like that. Because these are the things which generally people follow in daily life. But for expressing in physics, we use some prefix. So 10 raised to minus 3 means what? 10 raised to minus 6 means what? And you have to remember this permanently, because again and again you will need it. So my advice to all of you is that better take one small notebook and write these all things in it. If you find this blue table, it looks complex, then you can follow this one, where everything is written properly, say kilo, mega, giga, tera, peta, hexa. In general, up to 10 raised to 15, or at the most 10 raised to 18, plus or minus. Means if you go to the smaller side, it is femto, pico, like that, or atto we use. In daily life, 10 raised to minus 21, minus 24, or plus direction 10 raised to 21, 24. They are not used. But yet, we should know it. So, in small notebook, better write all these things, and twice a day, morning and evening, just have a look at it. But have a look at it means carefully you have to look at it. Then after some days, you will remember it permanently, because every now and then you will need it. One more thing you have to remember is this: while expressing this any physical quantity, there are some conventions or rules. Now look at this diagram, where it is shown that how to express it. For example, when you write that number, say 12.345 or whatever it is, then after that number you have to leave some space in between number and unit. Then you have to express the its prefix, means it is kilo, mega, giga, tera, like that. If there is a prefix, then you have to mention, otherwise leave it, and then you have to write the unit. And there should not be gap between the prefix and the unit. Here it is ml. ml, this m, bigger M stands for mega, and that L stands for liter, like that. So whatever may be the unit. If it is a meter, then small m you have to write. While writing small m and capital M, you should be very careful. Otherwise, it will convey the wrong thing, right? So for today's session, we will stop here.